According to the National Electrical Code, the described wiring configuration is non-compliant. Article 210.8 emphasizes that every circuit or conductor must be protected against overcurrent using a circuit breaker or a fuse. Article 310.14b16 specifies the ampacity of number 12 American wire gauge wire as 20 amps and number 16 American wire gauge wire as 10 amps. Article 210.20b requires that a branch circuit be rated for not less than the minimum circuit ampacity rating of the connected load. In the given scenario, a 25 amp circuit breaker protects the number 12 American wire gauge wire, which is rated for 20 amps, which is an issue in itself. However, the number 16 American wire gauge wire, rated for 10 amps, lacks individual circuit breakers or fuses. This absence of individual protection poses a significant safety risk because the total load on the number 16 American wire gauge wires could potentially exceed their ampacity rating, leading to a fire hazard. To ensure compliance with the National Electrical Code, specific changes are necessary. Firstly, install circuit breakers or fuses at each location where the number 12 wire branches out to the number 16 wire. Secondly, appropriately size the circuit breakers or fuses to protect the number 16 wire, which has an ampacity of 10 amps. Thirdly, thoroughly verify that the sizes of all wires and circuit breakers align with the load requirements and comply with the ampacity ratings detailed in the National Electrical Code. Let's delve deeper into each of these aspects, starting with circuit protection. Overcurrent protection is paramount in electrical systems to prevent overheating and potential fires. Circuit breakers and fuses act as safety devices, interrupting the flow of current when it exceeds the conductor's ampacity. The National Electrical Code mandates overcurrent protection for all circuits and conductors to safeguard against overloads and short circuits. In a given scenario, the 25 amp circuit breaker inadequately protects the number 16 American wire gauge wire, which is only rated for 10 amps. If the current exceeds 10 amps, the number 16 American wire gauge wire could overheat, causing insulation damage and potentially igniting nearby combustible materials. Next, let's consider conductor ampacity. Conductor ampacity refers to the maximum current carrying capacity of a wire or cable without exceeding its temperature rating. The National Electrical Code provides ampacity tables that specify the allowable current for different wire sizes and insulation types, considering factors such as ambient temperature and the number of conductors in a raceway. Article 310.15b16 outlines the ampacity of various wire gauges. For example, number 12 American wire gauge copper wire typically has an ampacity of 20 amps under normal conditions, while number 16 American wire gauge copper wire is rated for 10 amps. When selecting wire sizes for an electrical circuit, it's crucial to choose conductors with sufficient ampacity to handle the anticipated load. Using undersized wires can lead to overheating, voltage drop, and potential fire hazards. Finally, let's examine branch circuit ratings. A branch circuit is a portion of an electrical system that extends from the last overcurrent protective device, such as a circuit breaker or fuse, to the connected load or loads. The National Electrical Code establishes requirements for branch circuit ratings to ensure that circuits are adequately sized for the intended loads. Article 210.20b stipulates that a branch circuit must be rated for not less than the minimum circuit ampacity rating of the connected load. This means that the circuit breaker or fuse protecting the branch circuit must have an ampacity equal to or greater than the total load connected to the circuit. In a given scenario, the 25 amp circuit breaker exceeds the ampacity rating of the number 12 American wire gauge wire, which is rated for 20 amps. Ideally, the circuit breaker should match the ampacity of the wire. Furthermore, the number 16 American wire gauge wire is not protected by individual circuit breakers or fuses, violating the branch circuit rating requirements. To rectify these issues and ensure compliance with the National Electrical Code, several corrective actions are necessary. Firstly, install individual circuit breakers or fuses at each point where the number 12 wire branches out to the number 16 wire. These overcurrent protective devices will safeguard the number 16 American wire gauge wires from overloads and short circuits, preventing potential fire hazards. Secondly, carefully size the circuit breakers or fuses to protect the number 16 wire, ensuring that their ampacity matches or slightly exceeds the wire's ampacity rating. For number 16 American wire gauge wire, a 10 amp circuit breaker or fuse would be appropriate. Thirdly, conduct a thorough review of the entire wiring system to verify that the sizes of all wires and circuit breakers align with the load requirements and meet the ampacity ratings specified in the National Electrical Code. This review should include calculations to determine the total load on each circuit and conductor, considering factors such as voltage drop and rating for ambient temperature. In addition to these corrective actions, it's essential to follow best practices for electrical wiring and installation. Use appropriate wiring methods, such as conduit or cable, to protect conductors from physical damage. Properly terminate all connections and splices, ensuring that they are mechanically secure and electrically sound. Ground all metal enclosures and equipment to provide a path for fault current, reducing the risk of electric shock. Furthermore, consider the importance of electrical safety in the context of residential, commercial, and industrial environments. In residential settings, electrical safety is paramount to protect occupants from hazards such as electric shock, electrocution, and fires. Common electrical safety measures in homes include ground fault circuit interrupters, arc fault circuit interrupters, and tamper-resistant receptacles. In commercial and industrial environments, electrical safety is equally critical to prevent workplace accidents and equipment damage. Electrical safety programs in these settings often include lockout-tagout procedures, personal protective equipment requirements, and regular electrical inspections. Consider the specific challenges and considerations associated with electrical work in different environments. For example, electrical work in wet or damp locations requires special precautions to prevent electric shock. Similarly, electrical work in hazardous locations, such as those containing flammable gases or dust, necessitates the use of explosion-proof equipment and wiring methods. In conclusion, adhering to the National Electrical Code and implementing sound electrical practices are essential for ensuring the safety and reliability of electrical systems. By understanding the requirements for overcurrent protection, conductor ampacity, and branch circuit ratings, you can design and install electrical systems that minimize the risk of electrical hazards. The 25 amp breaker needs to be reduced to 20 amps to protect the number 12 wire. Each run of number 16 wire needs to have its own fuse or breaker rated at 10 amps or less. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about electrical safety.